Hello everyone. Today I am going to explain question number first and question number second of exercise 7.2 of class 12. As you can see, the question first is find the derivative of following function with respect to x. So here the function is sine inverse 2x root 1 minus x square. So this is our function. So in this exercise we are going to differentiate inverse trigonometric functions, and here some constraints are given to us, that is x is greater than minus 1 upon root 2 and less than 1 upon root 2. So we will start to solve it. First we will assume whatever function is equal to y. So y is equal to whatever function is given, we will write here and we assume it as equation first. Now to differentiate it, first we will try to simplify it. So for that we will do the substitution. Here we will assume x is equal to sine theta. From here, when sine will go here, it becomes sine inverse x is equal to theta. So this set of equation I named as equation second. Now, so in the equation first, instead of x we will replace sine theta. So when we replace the sine theta, here also sine theta will come and here also sine. So after replacement of x as sine theta, we will get the equation first as like this. Now root 1 minus sine square theta is cos theta. It is from the identity sine square theta plus cos square theta equal to 1. Now here when we observe, we found that 2 sine theta cos theta is the formula of sine 2 theta. That's why we will replace it by sine 2 theta. Now this sign and this sign can remove, but before that we have to confirm that this 2 theta will satisfy the given condition or not. So we will start from the given condition that x belongs between minus 1 upon root 2 to 1 upon root 2. Now x value, what is x here? Sine theta. So instead of this x we will write here sine. Now when we shift sine inverse in both the sides, the equation becomes like this. Now sine inverse minus 1 upon root 2, you know it is minus pi upon 4, and here sine inverse 1 upon root 2 is pi upon 4. Now what we have here? 2 theta. That's why this complete inequation will multiply by 2. So when we multiply this complete inequation by 2, we will obtain like this. Now we will start by what we have here, that is sine inverse x. So we'll decide whether the sine inverse principal value belongs to this or not. So we'll write here principal value of y is equal to sine inverse x is. So this we had already understood in second chapter, that the principal value of sine inverse x is pi upon open interval close interval minus pi upon 2 to pi upon 2, and here also we got the same. So that from equation 3, that is here, when sine inverse and sine inverse cancel, we will get directly 2 theta. That's why we will obtain 2 theta, and theta's value from equation second is sine inverse x, sine inverse theta, sine inverse x. Sorry students, here x will come. So write here sine inverse x. Now we will differentiate it with respect to x. So derivative symbol will come here also and derivative symbol will come here also. Here instead of theta, x should come. Now we will differentiate, and you know sine inverse x differentiation formula is 1 upon root 1 minus x square. So hence this first part of question number first is completed. Now we will move to the second part of question first. Now here we have to differentiate it again with respect to x, and this time x belongs to 1 upon 2 and 1 upon 2. So first we will assume given function as equation first, and here again we have to do substitution, and here if instead of x we will substitute here sine theta, then it will come in the form of sine 3 theta formula. That's why we will replace x by sine theta, and from here when sine will come here, theta is sine inverse x. Now we will replace, instead of x we will replace here sine theta, and after replacement, as I mentioned before, it is the formula of sine 3 theta. Now we have to see, can we cancel them or some other thing will come here. So first we have to write this, and then we have to check whether principal value is satisfying or not. So we write here that x belongs to this open interval given to us. So its meaning is this. Now x we had assumed here sin theta, that's why x will replace here by sin theta. Now take sin inverse to complete an equation, that will give you this. Now sin inverse 1 upon 2, and you know that sin 1 upon 2 is at pi upon 6, that's why its value is going to be minus pi upon 6, this theta as it is, and its value is plus pi upon 6. Now since we have here 3 theta, that's why multiply this complete in equation by 3. So it will give you minus pi upon 2, and here 3 theta, and here pi upon 2. And you know sine principal value is minus pi upon 2 to pi upon 2. So it is satisfying. So we will first write down the principal value is this, and then cancel here from in equation 3 sine and sine will remove, and we will get here 3 theta. So that this result we obtained from the in equation 4, and from equation 3 we obtained the sine and sine removed, and we got here 3 theta. Now theta value from equation 2 is sine inverse x. Now differentiate it with respect to x. So when you will differentiate it with respect to x, sine inverse x differentiation formula is 1 upon root 1 minus x square. So answer is 3 upon root 1 minus x square. Hence the first question is completed. Now we will move to the question number 2. Find derivative of given function with respect to x. So this time we have to differentiate it, and x belongs to open interval minus 1 to 1. Now again we will assume it as equation first. Now here instead of this x, if we have tan theta, then we know that it is going to be the formula of cos 2 theta. So that will give us hint that instead of x we should assume it as tan theta. So we will assume x as tan theta, and from here tan will go here. So it is going to be theta is going to be tan inverse x. Now we will do the replacement here. Instead of x we will write down tan theta. Now here when we put the value here, we will see that it is the formula of sine 2 theta, but we need, because cos inverse is outside, so here we need cos. So sine 2 theta, from complementary angle formula write down cos 90 degree minus 2 theta, that is pi upon 2 minus 2 theta. That is we know this formula from the 10th class onwards. So sine we had changed in terms of cos, so that they can remove each other. But before removing them, we should first check that whether the principal value is satisfying here or not. So since x belongs to the open interval given to us, now x we had assumed as tan theta. So take tan inverse in both the sides. Now tan inverse minus 1 is, tan 1 is at which value? Pi upon 4. So because of this minus sign, minus will come here, which we had done already in second chapter. Now in the same way, tan inverse 1 is pi upon 4. Now here what we have? 2 theta. That's why just multiply it by 2 in complete in equation, just multiply by 2. That will give you pi upon 2, here 2 theta, and here pi upon 2. Now from equation 4 and from equation 3, that is this in equation and from equation this 3, we observed that principal value is satisfying, that's why cos and cos will remove. Now how principal value is satisfying? Because we assumed x as tan theta, so y is equal to tan inverse x, principal value is minus pi upon 2 to pi upon 2. That's why it is satisfying. So we have removed. Now we obtained y as pi upon 2 minus 2 theta. Now we will differentiate it with respect to x. So when we will differentiate it with respect to x, we will obtain derivative symbol in both the sides. Now here since it's constant, that's why its differentiation is 0, and tan inverse x differentiation we know that is 1 upon 1 plus x square. So this is the answer for this question. Now the B part of the same question, that is question number 2. Now here again we know that if we substitute here tan theta, it is going to become in the form of cos 2 theta. So first we will assume the given function as y, that is first equation. Now for substitution we will assume x as tan theta, that will give us tan inverse x is equal to theta. Now in the question, instead of x we replace it by tan theta. Now it is the formula of cos 2 theta. Now before removing it we have to check principal values. So first what is given to us? Let's see in the question, x belongs to 0 to 1. So we will start here, x belongs to 0 to 1, and now x we had assumed as tan theta. Take tan inverse in complete in equation. Now tan inverse 0 is at 0 and tan inverse 1 is at pi upon 4. Now what is going to be here? 2 theta, that's why I multiply it by 2. Now we obtain this open interval that 2 theta belongs between 0 to pi by 2. Now we know that cos inverse x principal value is 0 to pi, and we know that whatever interval we obtain here is belonging in this interval. That's why our equation 3 is satisfying the principal value. That's why cos inverse and cos inverse will remove and we'll obtain here only 2 theta. Now theta we will replace by the equation second, that is tan inverse x. Now again we will differentiate it, so we'll obtain this. So that is the answer for this question. Hence question number second and first is completed. Thank you.